Good morning, participants of the CONIDA webinar. My name is Gasama Yushi from JAXA. I want to show you two videos today. One is the activity of JAXA 2019 to 2020. Another one is the history of the space development in Japan. So please go ahead. We know the space and they are improving our lives on Earth. This video is about the efforts from JAXA to progress in the aerospace technologies. Kibo is the experimental Japanese module completed its construction 10 years ago. Also 10 years ago, the first mission of the H-2 transfer vehicle Konnotori was launched. Konnotori I supplied cargo to the ISS and then introduced before the next generation transfer vehicle HTVX. Konnotori 8 has successfully completed all of its missions successfully. NASA and JAXA announced the Gateway Scientific and Technique worked together, the technical cooperation on the moon surface and their vicinity. The two organizations signed a joint statement. The Explorer Hayabusa 2 completed all of its missions in Yugu. It left. It will return in this December. The signals that we received at the Earth Station Hemisawa for the space exploration, deep space exploration. It will support JAXA's Martian moons exploration. By JAXA also for the space explorer missions of the foreign missions. Super low altitude satellite and Tsubame with ions and turbine in Japanese language. Tsubame acquired data of the atmospheric density and atomic oxygen and captured high-resolution images. The lowest altitude, 167.4 kilometers, is registered by the Guinness World Records as the lowest altitude by an Earth observation satellite in orbit. Earth observation satellites continue to monitor global climate change and large-scale disasters. The Today's Earth-Japan system was released using the satellite data to estimate the river discharge and flood area throughout Japan and providing prediction data. Since its release, several satellites with their respective advantages have performed observations. For example, of the Amazon rainforest wildfires and high-accuracy analysis have been conducted to promote such efforts worldwide. JAXA concluded an agreement with EUMETSAT for observation of greenhouse gases. JAXA has selected commercial users of ANATIS, aiming for efficient surveillance and inspection of large infrastructures such as rivers and airports. JAXA works as a private company in the creation of the project of food for space for the prevention of disasters. A new type of emergency food that can be consumed in space as well as during the disasters. JAXA undertakes partnerships with a variety of businesses, ranging from venture capitals to industry-leading companies in different business domains. Together, we create new businesses and innovation. The development of the traffic management system for UAS and manned aircraft system in the interconnection test Multiple drones were safely operated in the same airspace by 29 drone operators via the developed system. An automated SCARF sending device was developed in cooperation with China Industry. This device supports automated aircraft repair and saves labor in aircraft maintenance. By closely collaborating with industry, JAXA pursues innovation in the aeronautical technological field. Launching vehicle Callisto is developing into a joint project with France and Germany. As a preliminary experiment, JAXA performed a ground firing test with RVX, a small-scale experiment vehicle, at the Nusiro Center in Japan. The vehicle, H3 launch vehicle, is now in development in a collective effort by JAXA and corporations in Japan. Ground firing tests for the SRV-3 solid rocket booster were successfully performed. We completed a total of 31 actual model engine firing tests with the main engine LE9. The tanks using and the motor of actual rocket LE9 were used for the firing tests. In order to protect the satellites during the launching, a fairing separation was done. The development of the H3 launch vehicle is steadily advancing. From solutions for social issues to disaster measures and space transportation, our goal is to find new directions for the space industry. Please stay tuned to see how JAXA continues to lead airspace technologies. So, it was the video. Interesting or not? Let's see another video. The space development in Japan started with a small rocket, very small rocket, pencil-sized rocket, in Spanish lapis, pencil rocket. This is the first satellite from Japan, the Osumi. The weight is 23 kilos.
Hey, Jameson, I'm a Royal Boy. And liftoff of Endeavour on America's 50th space shuttle.
Thank you for your attention. Good afternoon, participants of the CONIDA webinar, SpaceTech 2020. Today, I would like to explain about the use of the Earth observation satellites and communications. My name is Masanobu Tsuchi from JAXA. JAXA is the Airspace Exploration Office from Japan. Let's begin. JAXA develops and cooperates on satellites, rockets, and an international space station of 15 countries. As you know, the airplanes fly at 10 to 12 kilometers. The cube is into the space over 100 kilometers, and 300 kilometers to 1,000 kilometers for all satellites. One round is 90 to 100 minutes. And the international station is at 400 kilometers. And the altitude of a satellite geostationary is of 36,000 kilometers. And it takes 24 hours to take one round of the Earth. The communication satellites and television use this orbit. The distance to the moon is 380,000 kilometers. It's very far, right? There are two types of sensors of the Earth observation satellites: optical sensors and microwave sensors. The Periusat 1 is one of the satellites with optical sensor. The sensors of microwaves, the radar active SAR, and the radiometer, passive radiometer. A satellite with data is ALOS, and GCOM-W from JAXA. This satellite observes the amount of steam in the air. Here we have some photos. To the right, the active data from SAR. You can see the boats, the vessels in this photo. To the left, we have a passive radio meter. The different colors show different ocean temperatures. The low image is of SAR, and the blue color represents the water. To the left, the mountains is clearer, and to the right, it's darker. Why? Because the microwave comes from the left to the right. The satellite to the left has a meteorological data. This data allows observing the distribution, three-dimensional, and the precipitation, the rains. There are two series of observation, the ALOS, ALS2, and 4. These are the satellites for climate change and water cycle, and the satellites for the observation of the greenhouse effects, monitoring of greenhouse effects. One of the important applications is the creation of maps. JAXA provides maps, 3D maps with a resolution of 5 meters. They are cheap. Resolution of 30 meters, that they are for free. For more information, you can please copy this website, this link. These are examples of the use of AW3D. The image on top is a combination of the optical sensor. In the photo below, it's used to search the location of a wind turbine. These are examples of observation of volcanic activity. Sakurajima is at 1,000 kilometers to the south of Tokyo. The city of Kawashima has a population of 600,000 inhabitants, and it is near this volcano. Observe the same place twice using this SAR data and this cycle of colors of 11 centimeters. The next image in 3D is a combination of ISA, in SAR and DSM. The photo to the right is a combination of the optical sensor and DSM. The satellite data are also used in the agriculture. JAXA provides information on moisture of soils, precipitation, radiation, solar radiation, temperature of the surface, Earth surface, index of droughts, areas with plantations, and the calendar of cultivations. or harvesting season. This is the map of with forests and non-forests in cooperation between JICA, the International Cooperation Agency from Japan, and JAXA. This map is used to control the satellite images are also used to mitigate disasters in the region of Asia and the Pacific. There is an activity called Sentinel Asia. The satellites of observation are in the LEO orbit, the low orbit, and the time of observation is limited for the area of disasters. We use some observation satellites of the constellation to observe more times. In the last 3 years, we have observed and provided images of more than 300 disasters in 30 countries. In Nepal, monitoring Nepal, the typhoon in Vietnam, forest fires in Australia, and landslides in the Philippines, flood in Thailand as well. We do not only provide photos of the observation satellites, but also analyze the data. The data from the observation satellite are also used to measure the greenhouse effects, and every year the concentration of carbon dioxide, CO2, and finally more than 400 ppms. We are creating the global map of precipitation, the GS map, using satellites of data of precipitation, radiometric of microwave and infrared images from the satellites, the data of the Asia region and the Pacific. They are almost in real time, and other locations in the Earth are hourly, and you may have access to the JAXA website or IRC, that our disaster center. Here there is an example of how we are using the information of the observation satellites in business. The observation from the DS map is used for the meteorological service in Jama. A person from the insurance used to go to this place and decided if they should take or not the information, the risks. But this insurance, the information from the GS map, is used to decide if to cover or not. Now I'm going to explain the use of the communication satellites. These satellites are being commercialized in Japan, but in some cases JAXA is also using them. Japan was hit by a big earthquake and tsunami in the year 2011. Many people died and the buildings were destroyed to the east of Japan. The earthquake and tsunami impacted the earth telephone lines and the base, leaving many telephones out of service. There was no power either. And at that time, the communication satellites, were very useful because since they are in the space, they are not affected by the earthquake or tsunami. And JAXA used 2 satellites of communications for the telephone and the access to internet in the area of the disaster. JAXA set up a small antenna at the office of the prefecture in the area of the disaster and provided a communication link. The other way to use the communication satellites is to the transmission of data relay. These low orbit satellites are only accessible through Earth stations 3 or 4 times a day, 15 minutes each time. However, we can send the data from the satellite of observation right away to the Earth station through the relay satellite. And also, besides the observation satellites and communication satellites, we also have the satellites for the positioning, navigation, and time or weather. Possible applications of the space technologies are the following. From the images to the left, we can observe how COVID-19 has reduced the amount of light in the city. And to the right, we measure the distance. To the right, we have a telemedicine, the remote construction, and also mining in Japan. I will close my presentation, but maybe somebody will ask me, why do I speak Spanish? The answer is in the next page. So these are photos taken in Chiclayo at the years 1989 to 1991, 30 years ago. I worked as a professor of electronics and systems. I was a volunteer of the program JICA GOCV. Thank you so much for your attention.